Good day, ladies and gentlemen. Um, Welcome back to my channel. And then in this video, I'm going to be looking at week 7 of our programming with C++ series, right? And then the topic for this video, the topic for this week is references and pointers, right? But then before we begin, let's look at what we call memory addresses. Okay, so first things first, we look at variables, variable declaration and variable initialization, right? And we said that anytime you initialize a variable, or you declare a variable, right, the computer allocates a memory to that variable where the variable is going to be stored, right? And then the name given to that memory allocation is what we call memory address. Alright, so um, when a variable is created in C++, a memory address is assigned to that variable. Then in order for us to access that memory address, right, we use the ampersand sign. So for instance, let's say I'm initializing a value, a string value called food. Let me put pizza here. Alright, and then I want to access the memory address, or I want to know where in the computer's memory this variable pizza has been stored, right? So I would like to display the memory address. In order to do that, I bring an ampersand sign, then I put my variable name here. Okay, so let's run this and see what we get. Good. So as you can see, we are seeing this hexadecimal value over here, right? And then this is the memory address of the variable food. Okay, so with that being said, let's dive into what we are actually going to be looking at today, that is references and pointers. Okay, so first of all, what are references, or what is a reference? So a reference is like an alias. When we say an alias, another name for something. Alright, so an alias or a nickname for a variable created or an existing variable. Okay, and then in creating a reference, you always have to initialize your variable. Okay, you always have to initialize your variable. What do I mean by initializing a variable? It means you declaring it and then giving it a value. Okay, so that is for reference. Yeah, let's delve in deeper. So for a reference, let's say I have this string here, the food string, right? And then I want to create a reference. I'm going to create a reference and I'll name it meal. Like I said, I'm giving it another name, an alias or a nickname, right? So I'm giving the food a nickname of meal. Now this is how we go about it. So I already have my initialized value here and I want to give it another name. So I'll do string. Then before I bring the other name, which is meal, I'll bring an ampersand sign, then meal. Okay, equal to the name of the variable that I want to nickname. You get? So I want to nickname the variable food. So I'm going to put food here. Okay, good. So now when I display, when I put meal here, right, and I run it, I'm going to get pizza, right? So let's see that. Good. So on a normal, I would have put food here to display the word pizza, but then I have given food another name that I can address it with. That is meal. And how did I do that? I brought the variable or the data type, that's the string, and then before I brought the nickname or the alias, I brought an ampersand sign. Then I equated it to the variable I want to name or I want to nickname. That's food, right? Then when I was displaying it, instead of me to type food, which is what we would do on a normal basis in order to display the string word pizza, I put meal here. Then when I run it, I'm going to get pizza because I've told the computer that meal is also the other name for the variable food. Okay, so yeah, in the same way, I can change the value of the variable food using the meal. So I can do meal is equal to let's go local fufu. All right. So when I display, obviously when I display meal, I'm going to get fufu. But then let's try something. Let's display food and see what we get. Good. So as you can see, I put food over here, but then I'm getting fufu. So this tells you that the meal is the other name for the food. Initially, the food was pizza, but then once I referenced food to meal, right, and then I changed the value of meal, which automatically changed the value of the variable food. Once I put food here and I run it, I'm not going to get pizza, I'm going to get fufu. Okay, so that is it for reference. That is it for reference. And then one thing you should know about reference is that the variable that you are going to be referencing must be initialized when you are declaring it. Okay, so the moment you declare the variable, you must initialize it before you can do anything of any sort of referencing or whatever you want to do. Okay, yes, so that is it for referencing. Let's move to pointers. So yeah, remember before I started this video, or when I started this video, I spoke of memory addresses and then yeah, and then the fact that once you create a variable, the computer allocates it to a memory, and then the memory has an address. Then the address is the location, or yeah, the location of where the variable is, right? And then we said that when I want to display the address of the variable, I do this food. All right, and then when we run it, we got the memory address of the variable food, which is this. Okay, good. So now this is what pointers do. So pointers are some sort of variables, right? But then what they store is that they store memory addresses of other variables. Okay, so pointers store memory addresses of other variables. So basically, a pointer is a variable that stores the memory address of other variables as its value. You understand? So yeah, basically a pointer variable points to a data type of the same type, and then it is created with the asterisk operator. Okay, so yeah, we have this line over here, right? Now I want to create a pointer. How do I go about it? So we look at the variable that we are going to create a pointer for, right? And we look at the data type of that variable, which is a string. So it means our pointer too has to be a string. You understand? So string, then you bring your asterisk sign. So your asterisk sign can be right after the string, or in the middle, or right before the pointer identifier name, so it can be any name. All right, but then ideally it is better for it to be here. All right, so we have our pointer string ptr for short, and then we equate it to the memory address of the food. And then how do we address the food? We use the ampersand sign, or it's also known as the address of. So ampersand sign, then food. Okay, so I'm going to replace this with the pointer. So I'll put ptr over here. Now I run it. You can see that it's displaying the memory address. Alright, so like I said, a pointer stores the memory address of another variable, or the variable it is pointing to as its value. Do you understand? Yes, so that is what a pointer does. Yeah, so I'm going to write some lines of code that is going to encompass what that I've said so far. You understand? For further understanding. So let's do that. Yeah. Let me just continue from here. Okay, so I'm going to make use of comments so that everything will be okay. So this is pointer value, pointer variable with the name ptr. Then I'm going to output the value of food. Right, so see out food. Then I'm going to output the memory address of food. Right, see out, then our ampersand sign, food. Okay, then our last line will be outputting the memory address with the pointer. Okay, good. So we already have that. Let me just add the end line, and let's run this and see. Good. So the first line is outputting the value of food, which is pizza. Second line is outputting the memory address directly, and we have this. And then the last line is outputting the memory address with the pointer. So we can see that this and this are the same. You understand? Yes. So exactly. We should note that the type of pointer has to match the type of the variable you are working with. Alright, so as you can see over here, because the variable I'm working with is a string, the pointer to was a string. If the variable I was working with was an integer, the pointer to would have been an integer. Float, same thing. Double, same thing. Okay, so yeah. The last thing, the last thing we'll be looking at is what we call dereferencing. Sorry, dereferencing. Dereferencing. So dereferencing is basically the process of using pointers to get the value of the variable using the asterisk operator. Alright, so it's quite simple. Alright, what do I mean by dereferencing? So we know that the pointer holds the memory address of the variable is pointing to as its value, right? So let's say I want to output the value of food using the pointer. All right, using the pointer. See out. Then before I bring my ptr variable, that's the pointer value, I'll bring an asterisk and I'll put ptr over there. Okay, so this is what we call dereferencing. Dereferencing. Let me run it. Good. So um, as we can see, the last line is pizza. That's this line, right? So basically, dereferencing is you getting the value of the variable the pointer is pointing to, right? We know that ideally the pointer holds the memory address of the value it is pointing to, but then when we say dereference, when we say we want to dereference a pointer value, what we mean by that is that we are using the pointer value to get the value of the variable it is pointing to, right? So let me elaborate on that. Our variable we are pointing to is food, which has a value of pizza, right? And then our pointer is storing the memory address of the variable food, right? Now dereferencing is the use of the pointer or the memory address to get the value inside that memory. So the memory address serves as a location, right? And then dereferencing is you going to that location and getting what is in the box or the house or the container or whatever is there. Alright, so that is what we call dereferencing. Okay. Alright, and yeah, so that is basically what reference pointers and dereferencing is all about in C++. It's basically used for it basically works with the memory of the computer. Okay, and you understanding this will help you manage your memory well, because it will prevent you from creating multiple variables, in some task or some program you are programming, right? And then the more space your program is taking, the less its speed. Um, yes, the less its speed and the less memory you use, the faster your program runs. Okay, so thank you very much, and I hope this video was helpful. Make sure you like, subscribe, and share. Thank you very much. God bless you.